Hey everybody, here are the notes for section 4.8. This is the last section we're doing in chapter 4 for a little bit. There is one more section in chapter 4, but it happens way at the end of the course, and when that happens, it will make more sense. But for now, here we go. This section is about using all of the things we did with factoring to now solve equations. There is one really important thing to note as we get going here. We're going to use this zero product rule, and then we're going to do some application kinds of things, but you should read to say word problems and not hyperventilate. It's going to be okay. But what we're talking about in this section are quadratic equations in one variable, which means there is a squared term, okay, and it's an equation. So standard form is going to be the variable with the highest exponent to the left. So in this case, it's x squared, an x, and then the constant, ax squared plus bx plus c equals 0. This is standard form. Remember that up until this point, what we have been doing is simplifying expressions. So when we're solving equations, there is an equal sign or an inequality sign, a less than or greater than, whatever. In this section, it's all equal sign. The thing is when you see an equal sign, that is when you solve for x. The rest of the time, when we see things like this that are just ax squared plus bx plus c, and there is no equal sign, when we see this, we simplify. Which I can't which I can't spell right now. Simplify. Whew. When we see an equal sign, we solve. Please be very careful. This sounds like a silly thing to be pointing out, but you will find an instance when suddenly you're trying to solve for x and there is no equal sign to solve for. So be careful to pay attention to the goal of what you're working on. When there is no equality sign, you're simplifying. When there is, you're solving. Okay, so the zero product rule is really important. What it says is that if a times b equals 0, then a equals 0 or b equals 0, right? Because we know that if I do 3 times 0, I get 0. If I do 0 times 3, I get 0. Something times 0 has to be set equal to 0. But what this lets us do is use factoring to solve equations. Okay, so when we're solving equations of this standard form, the first thing to do is always to get it into standard form. Okay, it's not always going to start out that way. Then we're going to factor using the steps that we know we've been using all along. Okay. And then we're going to apply the zero product rule. We can check our answers by substituting back in the original equation. Ooh, that just moved the whole thing. When we're talking about original equation, we're talking about the one before you rewrote it, the one printed on your page. Because if you rewrote it wrong or something went wrong, somewhere in between there, you won't know when you check if you don't check in the original equation. Okay, so here is one for us to solve. The first step is to look at it. Is it in standard form? Well, no, it's not, because it's got to look like this. Ax squared plus bx plus c equals 0. And in this case, I got 12 over there. So the first thing I'm going to do is put it in standard form by moving the 12 to the other side. So I get 2x squared minus 5x minus 12 equals 0. All right, now I'm in standard form. Now I have to factor. So now I have to look at what I have. Is there a common term? No. Nope, 5 isn't even, so I'm stuck there. Okay, well, I have a number in front of x squared. That means I'm going to use the AC test. So I'm going to do 2 times negative 12 is negative 24. I need two numbers that multiply to negative 24 and add to negative 5. That would be negative 8 and positive 3, right? So now I'm going to rewrite my negative 5 as negative 8x plus 3x. And I'm going to put everything else back. And now I'm going to factor by groups. Here's one group. Here's the second. Out of the first group, I'm going to take out 2x. So that's going to leave me x minus 4. And on the second group, I'm going to take out 3. It's going to leave me x minus 4, right? That gets me to 0. So now I'm going to bring my common binomial to the front, x minus 4, and gather up everything that's left. But I'm not finished here, okay? Don't lose your 0. So now, the third step was to apply the zero product rule. What the zero product rule says is that two things multiplied together set equal to 0 means I can set them both equal to 0. So what the zero product rule allows me to do, let me erase that up there real quick, is to say I have x, sorry. I have x minus 4 times 2x plus 3 equals 0. Now I can say x minus 4 equals to 0. I can separate them. And 2x plus 3 equals 0. And now I can solve them individually. Plus 4. So x is 4. And I'm going to solve this side. Divided by 2. Ooh. So x is going to be negative 3/2 or 4. So here's the thing. In this case, I have two answers, and I should in most quadratics. X is 4 or x is negative 3/2. You can go back now and check. What you are going to check, though, is this 4 and this negative 3/2 in this original equation. Go all the way back to the original. Put in 4 where you see x and see what happens. So I have 2 times, that would be 2 times 4 squared minus 5 times 4, and let's see if that equals 12. Well, 2 times 4 squared is 16 times 2 is 32. 32 minus 5 times 4, 32 minus 20. 32 minus 20 is 12, okay? So that checks. That's how you would do that. Let's try another one. All right, what's the first step? First step is standard form, right? So I'm gonna subtract 35 to the other side. So I'm gonna get y squared minus 2y plus 35 equals 0. Now I need to factor. There's no number in front of y, so I can just think about things that multiply to 35 and add to negative 2. Well, let's see. I need, oh, sorry, I subtracted 35. That should be a minus sign. It's twice I've done that already today in this video, sorry. So I need the signs to be different, right? Because I'm going to have a negative 35. So I need 1 minus and 1 plus. 7 times 5 is 35. I would need it to be a negative 7 and a positive 5. Still equals 0. Don't lose that, okay? So now zero product rule says I can write y minus 7 equals 0 and y plus 5 equals 0 and solve for y. So over here, I'm going to get negative 7, or sorry, positive 7. Whew. And over here, I'm going to get negative 5. And it's finished. Okay, let's try another one. Okay, so in this one, what do you see? Is it in standard form? Yeah, it is. Here's the thing. There's no additional C term, right? There's no constant number that doesn't have a variable. Sometimes there just isn't, and that's okay. So now let's factor. So stop for a second, excuse me, and think, what's the first step? Do you see any common terms? I do, right? Let's factor that out first. So I can take out 2x. That leaves me with 3x plus 4, 0. Well, here's the lovely part about this. Now I have two products, right, equal to 0. Now I can set them equal to 0. I don't have to do anything else. So here I am using the zero product rule. Here I'm going to divide by 2. 0 divided by 2 is just 0. Here, I'm going to subtract the 4. I get 3x equals negative 4 divided by 3. X equals negative 4/3. It's finished. That's it. Okay, when you see something like this, don't let it panic you. It's not the end of the world. Let's try another. Okay, is this in standard form? Surely not, right? It's got to be equal to 0 on the row, one of the sides. I'm going to move the 21 to the left. Then I'm going to get 9x squared minus 21x equals 0. So now what's your first step? Well, I see a common term, right? I can take out 3x. So I get 3x minus 7 equals 0. And now, once again, I have product times product equals 0, right? So I can set them equal. 3x equals 0. 3x minus 7 equals 0. Over here, divide by 3. X equals 0 still. Plus 7. 3x equals 7 divided by 3. X equals 7/3. All right, and here's the thing. This is just like a picky me kind of thing as a teacher. For me, it is entirely possible that you had a teacher in high school, or multiple teachers in high school, or teachers before me that said like, oh, if you have an improper fraction, you have to make it a decimal, or you have to change it into a proper fraction. I don't care. 7/3 doesn't hurt you. Okay? You do not need to change them into decimals. Please, please, please don't. Please just leave them alone. They're just fractions. They aren't going to injure you. You can make that 2 1/3 if you want, but you don't need to. So don't do extra steps that aren't necessary. Okay? All right, let's try another. Let's see what this kind is. Oh my goodness gracious. So we got a lot going on here to get this into standard form, just at minimum, right? So what's the first thing you have to do here? Well, for me, we can't put it into standard form with these parentheses right here, right? So what I need to do first is distribute. Okay, so I get 9x times 4x is 36x squared plus 18x minus 10x equals 8x plus 25. Whew. And the other thing I need to do is move all that stuff to the left because I need it to be on the other side. So I'm going to move it over. Minus 8x minus 25. And I'm going to kind of combine like terms as I go. So 36x squared is here. Plus 18x minus 10x minus 25. Well, those all kind of cancel each other out, right? Plus 18x minus 10 would be 8x. Minus 8x is no x's. So minus 25 equals 0. So I have 36x squared minus 25 equals 0. Ah, I see something. What do you see? I see a difference of squares, right? 36x squared minus 25. There's a perfect square here. The base is 6x. The perfect square over here is 5, right? So 2 parentheses, 1 minus, 1 plus. I get 6x is my first term, and 5 is my second, equal to 0. And now I can just use the zero product rule. 6x plus 5 equals 0. 6x minus 5 equals 0. Okay, now solve them. So here I'm going to subtract my 5. Here I'm going to add it. So here I get 6x equals negative 5. Here I get 6x equals positive 5. Divide by 6. Divide by 6. I'm running out of room. Divide by 6. For the first one, I get x equals negative 5/6. And the second one, I get x equals 5/6. And it's finished. It's done. Move on with your life. All good. All right. So try this one. Take a second. Multiply your way through. Okay. So let's see. We have to get rid of the parentheses first. So we have to distribute. Distribute there, there, and there. Okay. So let's see. In the first set, we get 10a squared minus 15a. And then we get plus 4a plus 4. And on the other side, I get 9a squared minus 6a. Phew. All right, so I'm going to combine some stuff on the right, on the left first. So I get 10a squared. 15, negative 15 plus 4 would be minus 11a plus 4. 9a squared minus 6a. And then I'm going to move all this stuff to the left, right? Minus 9a squared plus 6a minus 9a squared plus 6a. Okay, so over here I got a squared minus 5a plus 4 equals 0. You know, that turned out to be a much kinder and gentler thing than I expected with all that craziness at the top. Okay, so now factor. Let's think about what we have. There's nothing in front of a besides the 1, a squared, pardon me. So I need things that multiply to 4 and add to negative 5. This is a plus sign, which means either 2 positives or 2 negatives. It's a negative 5, so I need 2 negatives. And I think it's going to be negative 4 and negative 1, right? So a minus 4, a minus 1 equals 0. So now zero product rule, right? A minus 4 equals 0. A minus 1 equals 0. Plus 4 plus 1. And it gets me a equals 4, sorry, and a equals 1. Happy days. All right, look at us go. Let's try this one. All right, so this one, let's see, looks complicated. Again, first step is always standard form. That's not going to change, so I'm going to distribute here. So I get 2x squared plus 5, nope, not 5. I forgot to multiply the numbers. Plus 10x plus 3 equals 2x squared minus 5x plus 1. Now we got to move the things on the right to the left. So let's do that. Opposite signs, right? Minus 2x squared plus 5x minus 1. Okay, so those guys cancel. And I get 15x plus 2 equals 0. Well, hold on here. Wait a second. I don't have any squares left. So don't freak out. This is just a regular old equation now, right? I moved too much to the left because now all I really need to do is put that 2 back on the other side. And I get 15x equals 2, or sorry, negative 2, divided by 15. X is negative 2 over 15. That's it. I didn't need to even factor anything there. I just canceled all out. Lovely, isn't it? All right. This one works similarly because you can see it here, right? There's nothing to distribute. But when I try to move this over, those guys are going to cancel. And I'm going to have left negative 3t plus 1 equals 2t plus 11. From here, this is just treat it like a regular equation, right? You should get t equals 2 when you figure it out. Okay. Let's try another one. Let's see what happens here. This is crazy, right? This looks crazy, but stop. Your first inclination is to go, oh my gosh, I have to distribute everything here. But do you? What does the zero product rule say? It says A times B equals 0, right? What do you have here? Something times something times something times something. Okay. We can just set all of those equal to 0 separately. We don't have to distribute this. Once it's products like this, it's set. So I'm going to take each one apart. Negative 2 equals 0. Well, right off the bat, I know that's not right. I can ignore that. Y plus 7 equals 0. Y minus 1 equals 0. 10y plus 3 equals 0. This is way better than it could have been, right? Minus 7. So the first one, I get y equals negative 7 plus 1. Next one, I get y equals 1. And for the last one, I get 10y equals negative 3 divided by 10. Y equals negative 3/10. Happy days. Look, that could have been so much worse, right? Look at this one, the exact same thing. Do not feel like you have to FOIL all this. You can, but then you'll just have to factor it again, and that's miserable. What you're going to do is set each piece to 0. And solve. You can do this. Okay. This one is a higher degree polynomial, but it's not already all broken up. So we need to think about what to do with this. In this case, it looks kind of crazy, but I see ways that I could factor, right? I could treat this like a factor by grouping. Let's do that. Let's see what happens. So out of the first group, I'm going to take z squared. And then I'm going to get left z plus 3. All right. Out of the second group, I can take -4. Okay. Leaves me with z plus 3. Equals 0. Common binomial to the front, z plus 3. And then z squared minus 4 equals 0. Are we finished factoring? No, right? Because this second term here, this is a difference of squares. So I'm going to keep z plus 3 here. This is z plus 2, z minus 2 equals 0. And now I have products, right? I can just set them to 0. So z plus 3 equals 0, z plus 2 equals 0, and z minus 2 equals 0. Over here I get 3. Oh, sorry, -3. Over here I get z equals -2. And over here I get z equals 2. Ta-da, we're done. Let's look at the next one. We can do a very similar thing here, right? Do you see groups? I do. So do this one the same way we did the last one, okay? When you're finished, you should get x equals 3, x equals -3, and x equals 1. Oh, sorry, -1. Okay, try it. If you have questions about it, ask in the chat. All right, here's an application problem. This one says the product of 2 consecutive odd integers is 35. So how do I do this? Well, think about what makes a number odd, right? So if I have a number, let's call it n. N is a number. How do I get an odd number? Well, an odd number is different from an even number, right? The definition of an odd number is actually this, 2n plus 1. Anytime I take a number, n, let's call it 4, multiply it by 2, that would be 8, add 1, that's going to be 9, right? I have to multiply by 2 to make sure I get something even. Once I get something even, adding 1 makes it odd. So let's make 2n plus 1 the first odd number. What's the next odd number? Well, if I had that n was 4, right? 4 times 2 is 8, plus 1 is 9. What's the next odd number after 9? It's 11, right? How did I get from 9 to 11? I added 2. So if I did 2n plus 1 plus 2 more, I'd get the second odd number. So now it says the product of 2 consecutive odd numbers is 35. Well, let's see. Product, it would be 2n plus 1 and 2n plus 3. Product is 35. Okay? Do you see where all that comes from? If you don't, rewind. That's the joy of video. So now what do I do? Well, I have to FOIL, don't I? So let's see. Product, 2 4n squared. Or do I? Here's the thing. What do I have? I have a product, 0 product rule. So I could say 2n plus 1 equals 35, and 2n plus 3 equals 35, and solve. Let's see what I get. N is 17. Da, 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 32. N is 16. Okay. Is that going to work? Product of 2 consecutive odd integers is 35. Well, I know my numbers can't be 16 and 17 because those aren't consecutive odd integers. I had something go sideways here. Here's the thing, if you think this through, what do those numbers have to be? 2 consecutive odd integers make 35. Well, they make 7, like 5 times 7, wouldn't it? How do I get to those? I think this problem, that's right, I have a star in my notes that I think it's supposed to be a sum. I have done this every semester. So if we think about it this way, yes, it's supposed to be a sum, but you know what? If we did it as a sum, we'd get to the same place. It would be 17. This would be odd, and then if we added 2 more onto it, it would get us to 19. So we're going to do the second one because I forgot this one was funky. Just pretend that's not there. Let's try this one. Where are my notes? And this is also supposed to be, oh, let me see if it's supposed to be a sum or a product. Let me get my pen real quick to do something on the side. 2n. I know this is strange that I'm just sort of talking to myself for a second, but better to check, right? All right, so it'd be, oh yeah, that's gonna work out. Okay, I just had to check. It made me paranoid for a second. So 2 even integers. We went back here when we talked about add. We made it 2n plus 1. To get even, we just need the 2n. So I have 2n. That's going to be the first number, right? The second number is the next even integer. How do I get to that? So if n is 3, 3 times 2 is 6. How do I get to the next even number? The next even number is 8. Well, I add 2, right? That's the next or second even number. Okay. And then it says product. So 2n times 2n plus 2 equals 48. Ooh, that's a terrible 8. So how do we do this? We need standard form, right? So we need to distribute. So I get 4n squared plus 4n equals 48. I need the 48 to move left. So I get 4n squared plus 4n, and I'm going to subtract the 48. Minus 48 equals 0. So now I have to factor. Do you see a common term? For sure, I do. I see a 4, right? So I get n squared plus n minus 12 equals 0. Let's factor what's inside. So I need it to multiply to negative 12 and add to n. So that gets me, let's see, different signs, right? So it's going to be n plus 4 and n minus 3. All right, well, now let's use the zero product rule. 4 can't be 0. I get to ignore that. N minus 3 equals 0. N plus 4 equals 0. This is going to be n equals 3. This is going to be n equals negative 4. It can't be negative 4, consecutive even, or can it? Well, let's look. So if I do 2 times n, and I'd say n was 3. Let's change a color. If n is 3, 2 times n is 6. 2n plus 2 is 8. 6 times 8 is 48, right? If n is negative 4, 2 times n is negative 8. 2 times n plus 2 is negative 6. So either way, both of these will work, okay? Just 2 different answers to the same thing. All right, let's try something else. This one says the length of a basketball court is 6 feet less than 2 times the width. Let's stop right there. The length of a basketball court is 6 feet less than 2 times the width. Okay, so I don't know the width. Let's call that W. But I know the length is 6 feet less than 2 times the width, right? 2w minus 6. The area is 4,700 square feet. Find the dimensions. Wait, how do we find area? Area is length times width, right? So if I know area equals length times width, and I know the things that go here, I know this is 4,700 equals width 2w minus 6. Okay, well, I can now put this in standard form, can't I? Sure. So let's distribute. That's going to get me 4,700 equals 2w squared. Oh, wait, I don't have to do that, right? Even I do it sometimes. I can use the zero product rule. So, oh no, I can't. Why can't I? Because that's not a zero. Silly me. Okay, I need this to be in standard form, just like I was doing. 2w squared minus 6w. Now I need to move that 4,700 over to the other side. So now I get 2w squared, and I'm just going to switch it to the other side. It's a little easier to write this way. And now you're looking at yourself going like, oh my gosh, I have to factor this. Holy cow. Well, we can pull out a 2. That's a common term. Right? Let's make it at least a little easier on ourselves. Half of 4,700 is 2,350. And now I have to factor that inside. Well, you can think through, you should think through to see how that's going to go. Okay, see if you can factor it. But then I'm going to tell you, since this is going to be the longest video ever if we don't, that the factors are negative 50 and positive 47. So w minus 50 and w minus 47. So now we just use our zero product rule. We don't need to worry about the 2. W minus 50 equals 0. W minus 47 plus 47 equals 0. So W equals 50. W equals negative 47. In this case, do both of these answers apply? Will they both work for a width? No, right? Because if I said to you, oh, that basketball court is negative 47 feet long, you would look at me like I was a lunatic. So this one doesn't work. But W can be 50. So if width is 50, what's the length? Well, 2 times 50 is 100, minus 6 is 94. So 50 times 94 should, if you multiply together, get you 4,700. All right, the next one we're just going to set up. The width of a rectangle is 5 inches less than 3 times the length. Okay, so I know the length is just L. The width is 5 inches less than 3 times the length. Okay, so then the area is 2, so length times width be L times 3L minus 5 equals 2. All right, you should be able to figure this out. In this case, the length is actually 2. See if you can figure this out. Solve it, see what you get. All right. This one is an interesting one. Okay, so it looks scarier than it really is. A region off the coastline of Biscayne Bay is approximately the shape of a right angle. The corresponding triangular area has sandbars and is marked off on navigational charts as being shallow water. One leg of the triangle is half a mile shorter than the other, and the hypotenuse is 2.5 miles. Find the lengths of the legs. So here's the thing. When you see a right triangle, does a formula come to mind? Do you think of something important? I'm going to put a blank slide in right here. Sorry. What do you think of? I think of Pythagorean theorem, right? Do you remember Pythagorean theorem? A squared plus B squared equals C squared? Sure you do. Pythagoras is my favorite mathematician. He was a nut. If you didn't agree with his ideas, he would take you out in the ocean and throw you overboard. That's separate. So the hypotenuse is always C. So this is always going to be your C. The other two, whatever. So on the blank one, I'm going to do this. Let's see. So I have A squared plus b squared equals c squared. I know that the c squared is 2.5 squared. And you have your calculator now, right? You do? Okay, this is going to be x squared. And this is going to be x, I think it's minus, right? Minus 0.5 squared. Okay, so now let's deal with this. Here's problem number 1. What I cannot do, right here, I have this, right? What does this mean? What it really means is this. It does not mean ever to distribute that exponent. That is not how it works. You have to FOIL. If you distribute the exponent, you'll be missing a term and your answer will be wrong every single time. Okay, so this is going to be x squared, we FOIL, minus 0.5x minus 0.5x plus 0.25. Okay, so that's going to be x squared minus 1 whole x plus 0.25. All right, so now over here, I'm going to have x squared plus x squared minus x plus 0.25 equals 2.5 squared is 6.25. Now I just have to move that, get this into standard form, right? So I'm going to move 6.25 over and combine my like terms. So I have 2x squared minus x minus 6 equals 0. Well, that's not as ugly as it could have been, right? So now let's factor. It's an AC test, right? Because there's a 2 in front of x squared. So 2 times negative 6 is negative 12. I need to add and subtract to I need to multiply to negative 12 and add and subtract to negative 1. So that would be a negative 4 and a positive 3. So now I need to rewrite minus 4x plus 3x. And now what? We factor by groups, right? Here's a group. Here's a group. So then I'm going to take a 2x out of the first one. That's going to give me x minus 2. I'm going to take a 3 out of the second one. Going to give me x minus 2. Common binomial to the front. I'm going to do it over here. X minus 2. And collect what's left. 2x plus 3 equals 0. Okay, now 0 product rule. Okay, this is going to be x equals 2. That's going to be x equals, that should have been a, minus, that should have been a plus. That's a minus. That's a minus. That's negative. Minus 3/2. Here's the thing. This is Pythagorean theorem. It's about the lengths in a bay. So can both of my answers work? No. Negatives can't work here. So it's got to be 2. So you can go back here and find the dimensions. So this is 2.5. This is 2. And this is 1.5. Ta-da. All right. This was the same idea. We're going to draw the picture. You're going to solve it. The longer leg of a right triangle is 7 foot more than the shorter leg. So let's draw the triangle. It's a right triangle, pretend. So the shorter leg is x. The longer leg is x plus 7. The hypotenuse is 8 foot longer than the shorter leg. So this is x plus 8. Okay? So now, how does this work? A squared plus b squared equals c squared. X plus 7 squared equals x plus 8 squared. Remember, at no point are you allowed to distribute that exponent. Do not. It's bad, bad, bad move. FOIL and FOIL. All right, work it through. You should get x is equal to 5. Let's see what happens. Okay, I have faith in you. One last thing in this section. A, B, and C are real numbers, and A is not equal 0, then they make a quadratic function. What this means is that it makes a parabola. We're going to do more of this later in the semester. And that if the A in front of X is greater than 0, the parabola opens up. If it's smaller than 0, it opens down. So if it's negative 2x squared, opens down. If it's 2x squared, opens up. All right. So one of the things I can do with anything like this is find an x or y intercept. This is the spot where a graph crosses the x-axis, right? Remember? Oops. X-axis, y-axis, right? The intercepts are the place where the graph crosses there. Okay, to find an intercept, we want to know when a graph crosses the x-axis, it's at x equals 0. When it crosses the y-axis, it's at y equals 0. True? So I can find those. F of x is just fancy language for y. So really what I have here is y equals x squared minus x minus 12. To find the x-intercept, I put in 0 for x. So what I'm going to do is say y equals 0 squared minus 0 minus 12. Well, y equals negative 12. So the x-intercept is at 0, negative 12. Done. Okay? The y-intercept is at the spot where y equals 0. And so I'm going to write 0 for y equals x squared minus x minus 12. But at this point, this should look kind of familiar, right? This is solving a quadratic equation. So what I need to do on the right is factor. Multiply to negative 12, add and subtract to negative 1. We've seen that before today, right? Minus 4, x plus 3. We can solve. X minus 4 equals 0. X plus 3 equals 0. So x is going to be 4, and x is going to be 3. Oops, negative 3. So my coordinates, that's positive 4, good lord. 4 and 0, and negative 3 and 0. And it makes sense because this is a parabola, right? It opens up, and it would be down here at negative 12, and 4 and negative 3. It's kind of like this. That's our graph. All right, you're going to try it for the next one. Remember, this is y equals x squared plus 8x plus 12. X-intercepts are at x equals 0. Y-intercepts are when y equals 0. All right, one more thing, I think. So there's this idea that intercepts helps us with. It's the idea that if I take a rocket and I shoot it up in the sky, right, it then falls. The longer it's up in the air, it goes up, and then it comes down. So what it asks us to do is to find the height, h, when time is 0, when time is 5, when time is 10, and when time is 15, and determine what this means. So all it means when you see h of 0, h of 5, h of 10, h of 15, is that you're going to put 0, 10, 15, whatever, into the equation. Okay, so I'm going to find, when I find h of 0, I'm going to do this. Negative 16 times 0 squared plus 288 times 0. Well, that whole thing equals 0. So at time 0, it's on the ground. It's got no height. When h is 5 seconds after it launches, you can calculate this. You have a calculator. So 5 seconds after it launches, this is 25, negative 16, 5, 10, 40. So this is 1,040 feet. Okay, that's up. True? Okay. And then you do the same thing. At h is 15, it should be 720 feet. Where's 10? H is 10. For some reason, I don't have that one right in front of me. You can figure it out, though. So at h is 10, I don't have my calculator right here where I can reach it either. What's the difference between what's happening at 5 and what's happening at 10 is the question. At 5, it's at 1,040 feet. So it went from here all the way up to here, and then it's at 15, it's over here. Means it's starting to fall, right? Okay, what goes up must come down. Find the intercepts of the function and interpret them as time, okay? So we already found the x-intercept, didn't we? We did h of 0. So we did negative 16 times 0 plus 288 times 0. That got us this point, right? If I fill in 0 for t, sorry, h, pardon me. If I did it the other way, now I have to factor, right? So let's see. I can I pull out a common term? Yeah, I can. It's a negative 16 and a t. That would leave me t minus 18. Okay? So I get negative 16t equals 0, and I get t minus 18 equals 0. This is just going to divide through, right? Oh gosh, I forgot the t. And that's just going to be t equals 0. On this side, it's going to be t equals 18. Okay? So what's going to happen here is the height is 0 at that initial time, which we knew, and at 18 seconds. So here's time 0. Your rocket's sitting on the ground. It goes up, it goes down, and it falls when time is 18 seconds. All right, last part of this. We have to find what time it is when the rocket is at 1,152 feet. So what do? Well, we put 1,152 feet in for h. You can do this. This is calculation at this point. Standard form, right? Common terms, factor. There's actually two answers to this because my rocket goes both up and passes 1152 and down and passes 1152. So you should be able to solve this and find that this happens when time is 12 seconds and when time is 6 seconds. See if you can figure that out. If you have questions, ask, okay? All right, so this is the end of 4.8. We'll see you in the video for 5.1.